Welcome and good morning to all the students present in this video lecture. Let me introduce our syllabus which we are going to conduct in this semester, that is semester 4. So from the university website, if you all of you are familiar with that, from the website of GTU, that gtu.ac.in, you can be able to get this syllabus. So this is a Bachelor of Engineering program that is offered by the university, and our subject code is 31419006. Here 3 is having a meaning that it is revised third time. So our syllabus is revised in 2018-19. So this is, that's why it is here 3 is there. Then we have the 19 means our branch, and the 06 is your subject code. The name of the subject is fluid mechanics and the fluid machines. Actually, before the revision of the syllabus in the 2018-19, this is not the combined subjects. The fluid mechanics is offered in the fourth semester, and the hydraulic machine means fluid power engineering, that is offered in the fifth semester. But according to the new curriculum of GTU, that two subjects are combined in one subjects. That's why the name is like fluid mechanics and fluid machines. I think majority students are from the diploma side, so they know what is the basics of fluid mechanics and what is a fluid machines. So fluid is itself, there is a big word, and fluid mechanics means we have to study the motions, or at the rest conditions the behavior of fluids. And fluid machines means the machines which is operated under the motions of fluids. In these subjects, we have the 4 lectures as per the GTU teaching schemes for the regular curriculum, and there is no tutorial is there, and 2 hours of practicals. Means we have a laboratory session also. We have the 4 lectures, and the total credit of the subject is 6. And the assessment scheme is also given over here, that 70 marks of examinations that is conducted by GTU, then 30 marks of evaluation is there. It is a mid component, so we are taking the mid semester examinations. Then here we have the end semester examinations, that is a viva. So at end of the course we are conducting the viva examinations. And for the practical, we have also the internal, that is a progressive assessment component of 20 marks. So students, it is very clear, this component, the 70 marks of component, which is evaluated by the GTU for the end semester examinations. Here we are conducting also similar examinations like a GTU, but due to this pandemic situations, our classes are going on the online mode, so we are not able to conduct the 70 marks of examinations. Instead of that, in a regular interval, means every month after 4 week of time, we are conducting the exam of 30 marks. So there is a 3 exam we are going to conduct, and the average mark of that 3 will be put directly in this component. Then this is the end semester viva examination. That, so end of the semester we are conducting the viva, and from that we are putting down the marks out of 30 in this component. Here progressive assessment. So progressive assessment, that how you are regularly interacting in the practical and theory session, as well as there is a one lab manual is that you do not need to prepare that lab manual. We have already prepared it. You have to take a Xerox copy of that lab manual, and you need to write the practical readings. Means whenever you are coming over here, or we are conducting in live manner, at that time you need to write the readings of that, and you need to do the calculations, you need to prepare the graph, and you need to write a conclusion. So this is only the input which is required. But apart from that, whatever the regular interaction is there, as well as in every lecture, end of the every lecture, I'm going to assign you a lecture task. So lecture task and regular interactions, your attendance will all contain in the 20 marks. So I divide this 20 mark into 2 portions. That one is 10 mark, and another is of also 10 marks. So one 10 mark is content of the lab manual, another 10 mark is content of your uh, regular interactions and lecture task. Now we review the syllabus. So there is 4 hours per week is there, and if we calculate the 15 weeks of teaching, then there is 60 lectures are required to complete this course. Means we need a 60 contact hours for completing this syllabus. So here the total hours is there. So syllabus means first unit is there, the fluid and their properties. Today we are going to start this. So in this chapter we have to learn the basics of fluids and the different properties are there. In the second, we need to learn about the static forces on the surfaces and the buoyancy. Actually, students, all of you know that how the ship is floated. There is a buoyant forces are there. We know that some of the objects are floating on the surfaces of the fluid, and some of the objects are going inside the fluids. So that is depends on the buoyancy forces. Then the motions of the fluid particles and the streams. And then in fourth unit, we are going to discuss about the energy equation and its applications. Then in seventh, in the next, that is fifth lecture, fifth unit, we have a dimension analysis and similarities. Then here, see what exactly the meaning or what is the useful of this chapter number 5. That suppose I want to build the different hydraulic machines or any equipments which is having a fluid in concept, so we cannot directly generate or we cannot directly manufacturing of that equipments or the uh, we can say the components. Before that we have do some modeling. It means sheep cannot be directly built. Before the sheep, we need to reduce the scale and we make one model, and then we check the behavior of that sheep under the different conditions. And if the model is successfully run in the different conditions, or we can say that the simulations is done successfully in various conditions, then we are going for the manufacturing of the ship. Similarly, suppose we need to build a turbine, then we cannot build a turbine directly from the design. First we make some a model of that, and then we check, we find it out the different characteristics curve of that model, and then if it is satisfied with our requirements or the design criteria, then we go for the manufacturing of an actual equipments. So this is very important concept, that is chapter number 5. Then in chapter number 6 we have the viscous and the turbulent flow through the pipes. And in seventh, flow through the pipes is there, in which we are considering about the major and minor losses. In seventh, now from the chapter number 7, sorry, 7, then there is chapter number 8 is there, but it is the mistake. It is chapter number 8, 9 and 10. So these chapters, impact of jet and hydraulic turbines, centrifugal pumps and hydraulic machines. These three chapters are belongs to the hydraulic machine components. Means this three chapter is having, so if you calculate the 12 plus 6, 18 plus 20, so 20 hours of the teaching will be there for the hydraulic machines, in which there is only three components is there. There is no compressor is involved in this uh, fluid mechanics and hydraulic machines. In earlier we have the compressor also. Now here the suggested specification table is that there is a one significant representations of the distributions of theory marks, that your question paper is designed based on this specification table. See, actually it is the level of learnings. As all of you know, the level of learning, there are different domains of learning is there, like psychometric domains, then the affective domains. Cognitive domain is also there, and majority for the UG programs, means undergraduate programs, we are having a learnings in the cognitive domains. So in cognitive domains we have the different 6 levels of learnings is there. First is a remembrance, means what the thoughts you remember from the teaching learning process. How much understanding is developed in you, that is at U level. A means whatever the concept you learn in the subjects, that how you are applying for the given conditions. So in UG program we do not have the higher levels of learning, that is comes in upper semester of the UG program, or it is comes in the master level, that is the analyze, evaluate and synthesize or create. So we generally have R, U, and A level. R means remembrance level, U means understanding, and A means applications. So if you see here, the 50 percentage of mark weightage belongs to the applications. So in application, majorly what things are there? whatever the thoughts you have learned or whatever the cases of theory that you analyze, that is how you are applying for the given conditions. So actually in our layman terms or in general terms, we are treating this application level is a numerical. So in numerical, what happening, it is some certain conditions are given and you have to apply the concept of theory or the knowledge that you have gained during the learning period of your subjects, that you need to apply and you need to find it out whatever things is required, or it is say that you need to determine this concept or determine this value. So you can see that out of 70 marks, there is a 50 marks of question is asked from the application level. So students, you can understand the level of the subjects, what is the difficulty levels are there. 20 percentage of the question is asked from the R level, that is remembrance, means you need to remember it. Suppose some definition is there, certain principles is there, so you need to remember it. And the understanding means how you understand the concept thoroughly, so that is asked in the 30% of weightage is there. Now there are reference books are given over here, but we are using the textbook now. As all of you know that NBA accreditations is very important, and nowadays we believe in the outcome based education. As all of you know that since so many years we are say that our students does not have competencies, and that's why they are do not get the jobs in the real situations or in that professional career. So students, based on the NBA criteria, actually uh, in the early 80s and early 70s, the revolutions are take place, and the science courses are changing from science to engineering. And at that times the universal accords are forms. And in the recent periods, in the century of 2020, 20th century, the new accords, universally accepted accords are forms, and that is called as the Washington Accords. And it is an international accords for an engineering graduates in the world. And India is becomes also a signatory members of this accord at global level. So in India also, for the engineering courses, we need to follow the outcome based educations and the taxonomy which is generated by the Blooms. So see here, it is mentioned over here, it is a revised Bloom's taxonomy is there. So in line with these globalizations, in India, the policymakers are also changing, and India is become a signatory members of an Washington Accords. And then in India we have the outcome based education systems is famous in the engineering programs. So in line with this, we have defined the certain course outcome, means after attending this course, what competencies are developing the students, means see here it is a CO1, means course outcome 1. So after attending this course, student will be able to summarize the various fluid properties, means as you learn this course, after the course you must have the ability that you can be able to summarize various fluid properties and the behavior of fluids in static and dynamic conditions. Means there is some static portion is also there, there is some dynamic portion is also there. So you are learning the static and dynamic portions. Then the CO2 is to make a use of dimension analysis, interpret the types of fluid flow, and the experiment with flow through pipes. Means you will be able to carry out this all the three things which is mentioned over here, that is dimension analysis, interpret the types of fluid flow, and experiment with the flow through pipes. And CO3 is that to summarize the theory of impact of jet and apply the same for hydraulic turbines. Means you have a basic knowledge of and theories of impact of jet, and that you need to apply to the hydraulic turbines for an analysis. And the fourth CO is to make an calculations for the centrifugal pump and appraise various hydraulic machines. And these are the weightage is given, and according to this weightage your syllabus is designed. Like say the 60 hours is required, so out of that 44 percentage of time we need to spend on the CO1, and 24 percentage of time we need to spend for the CO2, that is a course outcome 2. So this is defined based on the contact hours between the student and teachers. And here some of the list of suggested equipments are given. We need to perform this practical in our laboratory. So first is a verifications of Bernoulli's experiment or Bernoulli's theorem. Second is to determine the metacentric height by metacentric height apparatus. So in our laboratory, we have all these facilities and we have all the practical apparatus is available. So whenever we are going to have the discussions on the various topic, at that time we are performing this practical. And if the situation is arises that we can able to call all the students to perform the practical in laboratory, as in previous semester we have 15 days of time for performance of a practical, so we can perform it. Otherwise you can refer my YouTube channel, and I have the performance of all the practicals in a virtual way for the theory, for the heat transfers. So similarly, we can also implement the virtual practical performance in the fluid mechanics and hydraulic machines. So do not worry about that, how we can perform the practical. So we can perform the practicals in virtual way also, as well as in physical classes also, if the permission is given by the our university. So this is about the syllabus and different topics that we have to learn. So the subject is, as all of you know, that fluid mechanics and hydraulic machines. In that, the chapter 1 is that fluid and their properties, and the today's topic is fluid and their properties. So introduction to the fluid. So see here, the fluid mechanics is a study of behavior of fluids either at rest conditions, or it means a fluid statics, and or in the fluids are in motion, means a fluid dynamics. So we can classify the fluid mechanics into two parts, that the behavior of fluid when it is at steady conditions we called as the fluid statics, and when we observe the behavior of the fluids when the fluids are in motion, at that time we called that we are studying the fluid dynamics. And combinedly fluid statics plus fluid dynamics is called as a fluid mechanics. So fluid mechanics is a study of behavior of fluids. But now the question is arises that what is the fluids? So we have the three different matters of substance, that is solid, then we have the liquids, and we have the gas. So combinedly, this liquid and gas is treated as a fluids. You also know it. But actually, the definition is of the fluid is the substance which have an ability to flow. Means we know that the fluid must have an ability to flow, and we know that the liquid and gases are flow under the different conditions, but the solid does not flow. And you, I think all of you know about the SOM subject, that is called as the strength of mechanics, or the solids of machines, solids of solid mechanics. So that is the subject that you have learned, that is a strength of material, in which you are observing the behavior of a solid. But liquid and gas we have called as a fluid because it has an ability to flow. And here the another things is that the analysis is based on the fundamental laws of mechanics, which is related to continuity of mass and energy with and force and momentum. So here we are doing the analysis of fluid based on the law of mechanics and the continuity of mass, as well as the energy with the force and momentum. So these are the very important terms which is related with the fluid mechanics. So it is very simple that fluid means the substance who have an ability to flow, and we have the three different matters of substances there, that is a solid, liquid, gas. And nowadays we also know the plasma is also one state of matter, but currently we are not taking that, we are going with a conventional one, and that is a solid, liquid, and gas. So liquid and gas is generally treated combinedly as known as a fluid because it has the ability to flow, where the solid does not have an ability to flow. So under these conditions, we are doing the analysis when the fluid is at rest condition, as well as fluid is in the motions. And understanding of the properties and the behavior of fluid at rest and in the motions is of great importance in the engineering. different properties, and every substance have a different behavior under the different conditions. And that's why it is very interesting subjects that we need to study the behavior of the fluid when it is in motions or when it is in rest conditions. So now next is the definitions of fluids. So fluid can be defined as a substance which can be deformed continuously when it being subjected to the shear force at any magnitude. This is a proper definitions. In layman terms, we can say that the fluid means the substance who having an ability to flow. In other words, it is can be a flow continuous as a result of shearing actions, and this includes any liquids or the gas. See here, this is an examples of less viscous, that is a water, and there is a high viscous of the oil. But now see here, what is a shear? See, this is one word which is very important. It is called as a shear stress. So first, what do you know about the stress? Suppose all of you know about the stress like this. Suppose this is an object which is a solid object, and here, if you apply the external forces, this is the external force that we are applying. So what exactly happens inside the solids? According to the Newton's law of motions, that is the third law, all the molecules are generating this resisting force. Suppose this is the P is external force, R is the force which is generated by these molecules. That's why it is called as a resistance force. This is the force applied from the external. So now this resisting force, that is R, which is equals to the P, that is the external forces, means this is applied for, and this is a reaction generated inside the solid substance. So stress is generally denoted by the sigma, which is equals to P by A, or we can write as R by A. Similarly, when you consider this resistance force, it becomes a stress which is generated by the molecules, and when you consider the external force, is called as a pressure. This is called as a pressure. So pressure and stress does not have the difference in unit, but there is a huge concept gap between these two. Pressure is when you consider the external forces, and when you consider the resistance force, then it is called as a stress. And stress is a properties of material. This is the properties of material, because how much resistance are generated, that is depends on the material of this object, where the pressure is measured by the external force, means how much the external forces that you are applying. And in this case of fluid mechanics, we are going to analyze the pressure, and that is external. So now see here, suppose I have the fluids. So fluid does not have any definite shape, and it can take the shape of any object in which you are filled. So see here, when the fluids is moved over here, then there is a shear stress is there. Shear means, suppose this is an object, and if you are applying force over here, then perpendicular to the actions of force, you consider that is called as a direct stresses or compressive and tensile. But when the force is parallel to the cross-sectional area, then it is called as a shear stress. So see here, it is the cross-sectional area, and your force is also parallel, or it is in line with this cross-sectional area. So this is called as a shear stress. So the shear stress at any magnitude means the fluid does not require a little amount of force you have given or you are applying to the fluid. It has a certain shear stresses between this layer of fluids, where in the solids you cannot have this. But after certain slides, we also consider that how behavior of the fluids are taken place. The density is, see, the density of fluid is denoted by the rho, so we are utilizing this rho. Definition is mass per unit volume, means the mass of an unit volume is called as a density. Mass is a quantity of matter, where the volume means the space occupied by a fluid, that is called as a volume. Suppose I have one this is my, I have one sub pan or one bottle is there, and I feel the liquids. So the space occupied by the fluid is called as the volume, and the mass is a quantity of matter, how much quantity is there. So we measure the mass in the unit of kg, where we measure the volume, there is a space occupied by an fluid, that is in meter cube. So from these two of different quantity, we can able to define the unit of this density, that is kg per meter cube. And the density is slightly affected by changing in the temperature and pressure. Means, as we know that the pressures, we all know that pvt equations for the fluid as well as for the gases, but in liquid it does not have so much amount of the effect of the temperature and pressure. So we can write that density is directly, or it is depends on, it is a functions of the temperature and the pressures. So this is the things, that the value of density is depends on the temperature and pressure. If you increase the temperature, then definitely we know that the volume is increases, because the volume is directly proportional to temperatures. And we also know that volume is inversely proportional to the pressures. So on the basis on this two relation, we can say that the density is having a relationship with the temperature and the pressures, and as you vary the temperature and pressure, it gets affected on the density. Now here you can able to remember it. The suppose you need to remember what is density, then it is mass by volume. So these the three formulas are there, which can be utilized for the different purposes for solving the numericals. Now it is mass by volume, the unit is becomes a kg per meter cube. If you are considering the cgs unit, then it is becomes a gram per centimeter cube. And the typical values, we know that we are considering the value of water, that density of water is 1000 kg per meter cube, or you can remember it one. What is one? One, that is a kg per liter. As all of you know, the liter is also the unit of volume, and we know that the 1 meter cube equals to 1000 liters. All of you are agree with this 1 liter? And for the definition, means the density of air is 1.23, is also vary with respect to the temperature, but it is at a standard STP conditions, standard temperature and pressure. We are generally taking as a 1.2, or rounding of it is taken as a 1. So you need to remember it, because this is a two and ideal fluids. Suppose we are talking about the liquid, then we are taking the reference of the water, and if we are talking about the gases, then we are taking the reference of air. So you need to remember this value. Now the next properties, that is called as a specific weights or the weight density. It is indicated by the gamma. So the definition is weight of the fluid per unit volume. And we know that weight means the mass multiplied by the gravitational acceleration. So arising from the existence of gravitation force, the relationship between the gamma and g can be found using the following relations. So we know that the density equals to mass by volume. Therefore, the specific weight equals to rho into g, as we know that the mass into the g is there divided by v. So this is becomes a mass into gravitational, that is called as a weight. So we can write as a w by v also, and w equals to mg, and we can know that m by v into g is there. So m by v is your rho. So finally we get the equations, that is rho into g. And the unit, we know that mass is multiplied with the acceleration, so it becomes a newton, because m, we know that the unit of g is meter per second square, and the unit of mass is kg. So finally our unit is becomes a kg into meter per second square, and this is nothing but a newton. So our answer is becomes a newton, and the volume having a units of meter cube. So we get newton per meter cube. Then the typical value is also given for the water. It is a 9814 Newton per meter cube, and for air it is a 12.07 Newton per meter cube. You can be derived easily from the previous value, that is a density. So student, you must have to remember this value. Now next is specific gravity, or it is called as relative density. It is very important whenever, see students, all of you are using the two-wheeler and you are going to fill or petrol or diesels. At that time specific gravity is mentioned over there, or it is called as a relative density. This word is very important, relative density. So there is a two definitions are there. So a ratio of density of a substance to the density of water at a standard temperature, that is a 4 degree, and atmospheric pressures. Atmospheric pressures means 1 atmospheric pressure, that is called as a. And second is the ratio of specific weight of the substance at specific weight of water at and standard temperature, that is a 4 degree, and atmospheric pressures, that is called as a specific gravity. So we can call it as a specific gravity is having the density of a given substance or the density of fluid divided by the density of water. So this is the important concept, and basis on the relative density concept, we can identify the fluid is heavier than the weight or it is lighter than the weight. If the density of fluid is higher than the water, then it is called as heavier, or it is having a light, then it is light. Suppose we are taking the petrol, so the specific gravity of petrol is comes near about zero point 0.8. So if you have mixed the petrol and water, then definitely the petrol will be floating on the surfaces of water, and this is happens because, and you can justify it from this specific gravity. And students, I want to emphasize over here, if you are taking about the gas medium, then for the gas we need to take the density of any gas divided by density of air. So specific gravity for the gas is defined as the density of the gas divided by the density of air, that is 1.24 or 1.23. Clear? So it is dimensionless because the unit of density of any fluid is kg per meter cube, and we have the same, that is a kg per meter cube. So it is cancel it out and we get the dimensionless units for the specific gravity, or it is called as sg, it is indicated by sg. So just I want to summarize that what we have learned today. We have learned what is the, we start with the syllabus, what is the importance of the fluid mechanics and hydraulic machines in our mechanical engineering curriculums. Then we have discussed about the, then we have discussed about the in detail of the syllabus. Then we start with the chapter number 1, that is a fluid and their properties, and in that we have discussed about the basics, that is a fluid mechanics and fluid statics. Then we have discussed about the density, viscosity, and specific gravity. So with this word I end this session. Thank you for attending this lecture.